I am the king of fishing. One day, baby raccoons were playing marbles.
Here goes my marble.
Me too. Yay!
Here I go. It's fun.
So fun. I think I have the most marbles.
Nope. I have the most marbles.
No, I have the most marbles.
Baby raccoons didn't know who had the most marbles. That's because they didn't know how to count yet. But don't worry, I have a great idea.
How about we put our marbles in one line?
Wow, let's do that.
Spotty, you're so smart.
Here are my marbles.
Here are my marbles.
Here are my marbles.
See, mine is the longest, so I have the most marbles.
What? Mine is the shortest. I have the least.
I, Spotty, am king of the marbles.
I want to be a king of something. Would you like to go fishing?
Fishing?
Yes. Whoever catches the most will be the king of fishing.
The baby raccoons ran to the stream.
Wow! There are a lot of fish.
I caught one.
I caught one too.
Oh, I'm not sure who has the most fish by looking at it like this.
Should we line up the fish like we did the last time?
Yeah,
sounds great.
The baby raccoons put the fish side by side.
These are my fish.
These are my fish.
These are my fish.
See? This time mine is the longest.
Then does that mean Dusty has the most fish?
Of course.
Wait, there's something wrong. Look at this. Although the line is shorter, I have the most fish.
You're right. It looks like Dusty has more fish because they're bigger.
Oh, really? Yes, the fish sizes are different.
Marbles are the same size, so they were easy to tell.
What are we supposed to do now?
There's always a way.
Hey, Brother.
Look carefully. We have to do this differently.
Differently?
Buddy's brothers started to draw lines on the floor. Now you have to put one fish per column.
One fish per column.
One fish per column. One fish per column. One fish per column. Wow, by doing this, we can see who has the most fish.
Spotty's brother marked each fish in the column with a red stick. Graphing makes everything easier.
Graphing?
Wow, Big Eye's graph is the longest.
The next longest is mine.
And the next longest is mine. Then who has the most fish?
Big Eyes has the most fish.
Yay, then I am. Big Eye's the king of fishing?
Yes, King.
Everyone follow the king.
Wow, this looks delicious.
As king, it is my command for everyone. Eat a lot.
Yes,
Yes, sir.
Instead of counting, the baby raccoons used a graph to see who had the most fish.
Hello everyone, how are you? Do you love the story? I love it. What did you learn from the story? Yes, we learned that math can solve everything. By graphing, the friends know who had the most fish. Yes, so math is the solution for every problem that you can face it. Here is the lesson for today is about partition figure. In this lesson, we will call the fraction. You remember the fraction? Perfect. Fraction is part of a whole, equal part of a whole. So here we will see how we will express fraction with area. Like if I have a whole area and if I want to partition the area into equal parts, each part represents a fraction. Let's see now. Do you remember the unit of fraction? Yes, the unit of fraction has a number which is number 1. Where I put number 1? Excellent, in the numerator. So unit of fraction, all the time the numerator is number 1. You remember the numerator? The numerator is never under. And the denominator, perfect, it's down. So when I have the unit fraction, 1, it's in the numerator, and the total or the whole in the denominator. Let's see here. The first thing, the figures below are partitioned or divided into equal parts with the amount of each part. So here I have a whole of circle. I partition this circle into 2 parts. Are these parts equal? Yes. So because they are equal, I call them half. So 2 parts are equal in area. This area for this part is the same area of this part. So I'm expressing fraction to or expressing area by fraction. So each part is a half of the area of a circle. Again, let's see another example. If I have a rectangle, I partition the rectangle into 6 equal parts. So 6 parts are equal in the area. Each part is a unit fraction. It's 1 out of 6 or 1/6 of the area of the rectangle. So here is 1/6, here is 1/6, here is 1/6. I have here 6 parts. All of them are equal. Another example. I have this rectangle. I partition this rectangle into 3 areas. Each area represents, yes, a third because they are equal. So 3 parts are equal in area. Each part is a third of the area of a rectangle. Also here I have a circle. I partition the circle into 8 parts. The 8 parts are equal in area. Each part is 1/8 of the area of the circle. So all the time in this lesson I'm dealing with the unit fraction. Unit fraction means we have 1 up in the numerator. So as I told you, a unit fraction is a fraction with the numerator of 1 and the whole number is the denominator. Remember the unit fraction, 1 in the top all the time, 1 in the top all the time. A figure can be partitioned into equal parts in different ways. The unit fraction 1/4 of each figure had the same area. So here as I have, this is a square and here is a rectangle, yes. So I can make and partition my figure into 2 different ways. But the fourth is still the same for both areas. For example, let's see. If I have this, the length here is 4. And for example, yes, here is No. Here is 4 and here is 4. Here is 8 and here is 2. Perfect. The area for the first square is 16. 4 multiplied 4 is 16. And the area for this rectangle is also 16. 8 multiplied 2 is 16. So a quarter, a fourth of the rectangle with 16 square units is the same quarter for the square of 16 square unit, even if I have different shapes. So here is I'm talking about the area which is inside, not outside. Look here, this is the first practice in your textbook 484. Match each unit fraction to figure that shows the correct shaded part or correct shaded area. Look here. Let's see. Number 1. Here is I have 4 equal parts. Each shaded part is what? Perfect. Fourth. Here is how many parts I have in all? 1, 2, 3, 4, 5, 6. Here is what they call the shaded part. What the area of this part? Excellent, it's 1/6. 1/6. And here is 1, 2, 3, 4, 5, 6, 7, 8. Excellent, 1/8. Where is 1/8 here? Perfect, this one. Here I have 1, 2, 3, 4, 5, 6, 7, 8. This is 1/8. It's the same. And where is 1/4? And here is what? 1/6. So it's the same like a fraction, but I'm expressing the area calculation during the fraction. Circle all the figures that show the same unit fraction of the area. For example, if I have this circle and I partition the circle in this way, the area will be the same. Or I have the same circle and I partitioned in this way, the area will be the same. But I can see this part is larger than my unit fraction. So, yeah, this is not with them. And is this the same half? Yes, it's the same. So here I circle the first one, the second one, and the third one. So here is I'm circling all the figures that show the same unit fraction. The third one doesn't show the same unit fraction, even though it's an equal part. Let's see here. Here I have this one is 1 out of 6 because I have 6 equal parts. Here is also 1 out of 6 because I have 6 equal parts. Here is I have 1 out of 6 because I have 6 equal parts. But here I have 1/2. Only I have 2 equal parts. What are the figures that show the same unit fraction? Amazing, the 1/6. This with this and with this. Let's see the next. This shaded part represents 1/4 and this shaded part represents 1/4 of the area, and this shaded part represents 1/4. But this part is an equal part. So the area for this part is not the same of 1/4 or the unit fraction for the first 3 squares. So this is not with the group. Only the first 3 unit fraction. Partition each figure into the number of sections, giving right the number or the unit fraction for one part of the figure. So the first job that you have to partition. Teacher, how many parts? They wrote for you. I want here 3 equal sections. So if I have this is a table and I want to measure the area of a part of my table, but I want to share it with the 3 friends, I told them, okay, each boy will measure a part of that circle and should our part be equal? Do you remember how we partition a circle into 3 equal parts? Perfect. We go as when we cut it in the pizza slice. So I make a center and then I make a line up and I will draw the peace sign like this and like this. Now really I have now, yes, what? X and 3 equal section. The second thing that I have to do is write the unit fraction of one part. So I have to shade one part of this area and write the unit fraction of it. Simple, easy. Number 3, I have fourth section equal. So easy for 4, it's just drawing 2 lines like this. Yes, and here is my unit fraction is 1/4. I want here 6 section. Yes, so I have to draw yes, 3 columns and 2 rows. So let's draw, or as you want. So for drawing 3 columns I have to draw 2 lines. For making 2 rows I have to draw only 1 line. The unit fraction is 1/6. 1/6. 8th section. 8th section. I can make 4 and then divide the 4 into 2. For example, if I want to make 4 columns, I need to draw 3 lines. This is the first line, this is the second line, and this is the third line. Now I have 4, but I want 8. Yes, just I make 1 in the middle. Now I have 8. I want the unit fraction 1/8. Yes, it will be like this, 1/8. Perfect. Okay, let's see. The problem solving. I don't know why I lost pages. Okay, let's see now. Flex says I can partition this pie into 8 equal parts in different ways, and the fraction of each part of the pie is still the same. Do you agree with him? Yes. Look at this pie, and it's a circle. Can you partition a circle into 8 equal parts with different ways? Huh? Let's see what he said. I can partition this pie into 8 equal pieces in different ways, and the fraction of each part of the pie's area is still the same. So if he partition the first like this, and then this is the first, okay? Or I have the pie here. I will not make the part first here. For example, I make it like here. Right? So yes, I can partition the pie into different ways, but still my eighth will be, yes, the same. So the eighth will not change from different partition. If my parts are equal, and for sure I have 8 in any for the same pie, that means I have the same 8 even if I partition it in different way. So we have to say yes, Felix is correct. Felix is correct. Here is the vocabulary. Is a number that represents part of whole. A part of whole, equal part of whole, perfect, it's a fraction. Number 2 is the measure of the number of unit squares needed to cover a surface. Unit square. Unit square, yes, a measurement, not only unit square. Perfect, it's area. Here is your homework. It's about matching. Where is 1/3? So easy. 1/3 also, so easy. 1/2. Perfect. 1/2. Perfect. Where is 1/6? Yes, where is 1/6? Perfect. Write the fraction for the shaded parts. So easy. 1 out of 2. And here is 1, 2, 3, 4, 5, 6, 7, 8. 1 out of 8. And here 1, 2, 3, 4. 1 out of 4. So this is the lesson for today. There is a missing page. I will put it right now. Just wait a minute. Okay. Here is the problem solving, page 486. Madison, Leila, Omar, and Rashid decided to make a rectangular quilt together. The work is equally divided and each person makes a fourth of a section. What fraction of the quilt will each person make? Draw a picture of the quilt. Yes, how many people I have? Let's see. I have 1, 2, 3, and 4. Okay? They want to make a quilt together. Yes. So my rectangle will be partitioned into how many parts? Amazing. Into 4 equal parts. This is the rectangle. Here is the 4 equal parts. Each one will take what? Perfect. Each one will take a fourth. Now Eva partitions 2 same size cake into 5 equal parts each. Does each of the 10 parts have the same area? And explain. Yes. So let's draw the cake. Here as I have the 2 cake. This is the first one and here's the other one. Yes. Eva partitioned 2 same cakes into 5 equal parts. So let's make 5. Yes. I'm trying to make it 5. 1, 2, 3, 4, 5. Yes. 1, 2, 3, 4, 5. So yes. So does each of the 10 parts have the same area? Yani I have 5 equal here and 5 equal here and the cake is the same. I didn't change the cake. So if I have instead of for example, if I'm talking about here, it's 1/5. But if I want to talk about the two cakes together, can I say that the 1/5 it's only 1/10? And you have to know that the two cakes are the same in size. Yes, for sure, yes. The area of the top of each cake is the same. So the 10 part should have the same top area. So you have to say yes. The area of the 10 parts have the same. Yes. Yes, here is a game about fraction. Here is I have to say the equivalent fraction. 2 and 3 will be what? Perfect. Now, what about? Yes. Wait. Yes, 9. And also 9. And also 9. The fraction equal, yes. If I want 3, 9. 9. Now up, I guess it will be 3. And here is 9. Yes, here is 2 multiplied by 2. It will be 4. 6 3 multiplied by 4. And here is, come on, 3. Yes. Very nice. So here is shows and reminds of the equivalent fraction. It's so scary game and I love it. I will put the game link under the video in the YouTube, the first comment. So just check it there and go and have fun with these zombies. See you later.